Today we're going to continue looking at RepRap Firmware and some of its more advanced features by taking a look at Pressure Advance. What's up everyone, Chris here, and if you remember over 2 years ago I did a video on Linear Advance, and that's available in Marlin firmware. Well, Pressure Advance in RepRap Firmware tries to achieve the same thing. Basically, we're trying to compensate for the elasticity of the filament and the extruder that is posed on your 3D printer. And that's kind of easy to say, but a little bit harder to explain. But that's what I'm going to try to do today. I'm going to show you what prints look like without it, with it, show you how to get it all set up, and this is all going to be revolving around the Duet 2 Wi-Fi, but pretty much anything running RepRap Firmware, even version 3, is going to be very similar. Now, what about different printer setups? This one right here is running in direct drive with a Hotends, so you don't have a tube feeding the extruder. The filament goes right into a set of gears with a relatively short filament path. Well, it's going to be completely different on a Bowden setup, where you have a tube feeding your hot end where the extruder is separate. So we're going to take a look at both setups, because they're going to react just a little bit differently. Also, you have to think about different types of filament. Not all are going to behave the same way, but we'll try to go over all those things. So let's start by taking a look at a print that doesn't have it turned on. So here's our first test cube. Don't worry, you're going to see a lot of these today. Please ignore this line right here. I do have a bit of layer shift. I was playing around with motor current, but that's not going to impact what we're talking about today. So take a look at the corners of these prints. The effect of this feature is going to be most noticeable on sharper corners. You can see from this angle that it's actually bubbled out just a bit. And if I turn it, you can see how it's even more prominent. The corners almost look pinched. And that's because of the flexibility in the filament and just how the extruders work. So when you're printing, you go from a dead stop, you enter acceleration, and then you have to decelerate. And that linear motion is all fine and good, the printer's able to handle it, but the extruder doesn't really react the same way, because you're driving a gear. Also, if there's elasticity introduced by the filament or even a Bowden tube, it's going to be really hard to slow the filament down to keep it from extruding and over extruding when you're trying to change direction. And that's where Pressure Advance comes in. With Pressure Advance enabled, as you start to reach the corner where you're going to change direction, it pulls back on the extruder just a bit so you don't over extrude and the corners become much sharper. Now, there is a happy medium here and everything has to be calibrated, and this is no exception, but let me show you a print where a direct drive extruder has been calibrated for Pressure Advance. This is a Pressure Advance setting of 0.02, and we'll get more to what those settings mean here in a moment. But you can compare this corner, it's not near as pinched with Pressure Advance turned off. You can even take a look at the top. You can see the corners are a lot more even. And if we compare it to the print that has it turned off, you can tell that these corners are just a little bit more pulled out. These corners are much sharper. Again, here's the profile without. Here's the profile with it turned on. So basically, we're just trying to compensate for that extra amount of filament that's going to get extruded while the printer slows down and tries to change direction. And that does help in a lot of different areas on the prints, not just in the corner. And it can also help with retraction settings, but we'll talk more about that in a moment. Now, what is the best way to calibrate Pressure Advance? Well, Duet, as always, has a ton of information on this subject. So here's all the information on Pressure Advance over on the Duet site. There's a lot of stuff out here. I will leave a link in the description, of course. But read through some of this, it might make just a little bit more sense. But there's also some recommendations on this page. So as we saw on my direct drive extruder, that is again the Hotends, I have a setting of 0.02. Now the corners were just a little bit too sharp. They could be a little bit more rounded. You saw on the after the change, they were just a little bit pulled out still. So I might still want to go up to a 0.25 like it suggests right here. So the Duet recommendations for PLA, remember it's going to be different on every filament. It is pretty close for my current setup. Now they also have suggestions if you're doing a Bowden style printer. and they go by the length of tube. Now these settings are a little bit off from what I've found. We will go over that further, but you might want to start here and then ramp up from there. But that's what we're going to test. They also have a lot of great information about how you can calibrate Pressure Advance. There's a couple of different methods. I'm going to show you a couple as well because we're doing a video on it. The steps that I'm going to show you are also down here on this page. It'll walk you through them. But controlling Pressure Advance, you use the M572 command in RepRap Firmware. But one of the easiest ways to test this and get it dialed in is just to create a single or double wall print, and you have to situate it in a certain way, but then increment your 572 command so you can see it making changes as it gets taller. And I use Prusa Slicer, so this block of code right here, you can just copy and paste this in your G-code settings, and then you can increment it as you see fit to adjust the Pressure Advance. So if we head over to Prusa Slicer, I'm going to pull in a box that's 100 by 100 by 80. It's actually a 40 cube. I just stretched it with scaling, but this is going to work for this instance. This gives me 400 layers at a 0.2 layer height. I'm going to set the infill to 0. In print settings, I'm going to do 1 perimeter, 0 top layers, and 1 bottom layer. Now, based on your minimum shell thickness, it might actually do more than 1 bottom layer. It just depends how it calculates it, but that's not going to hurt this test any. The most important setting is we need the seam on this print lined up. And in Prusa Slicer, the easiest way to do that is to come down here to seam position and just make it line up in the rear. That's going to stack it perfectly right in the middle of the back of the print. So if we go back to the platter and we slice, you can see our single wall print. If we turn it a little bit, you can actually see that seam right back here. Now, we want our Pressure Advance setting to be somewhat automated so we can see as it makes changes. So we're going to head over to Printer Settings, Custom G-code, and then in our Before Layer Change, we're just going to paste in the settings from that Duet page. So on my settings, for the first layer on to 25, I did a Pressure Advance setting of 005. This is very granular. You don't necessarily have to do this. Maybe just go in whole numbers for the first test. I just wanted to show you how it's going to turn out. But I went all the way to layer 350 in increments of 25 until I got to 075, which is pretty high for a direct drive extruder, but we'll talk more about that when we get into Bowden. So again, just paste the code that Duet gives you. Links will be in the description, and then you can play with these final numbers while you're dialing it in. Now there are a couple more settings that you need to be concerned with when you're testing Pressure Advance. Some of them are machine settings. We'll talk about those in a moment. But as far as the slicer goes, you don't want anything that says anything about coasting or wipe while retracting. Those settings are trying to achieve some of the same results as Pressure Advanced, and they can get it confused just a little bit. So you really don't know what's impacting the print as you're doing your calibration. So I suggest you just turn these settings off. In Prusa Slicer, they do have wipe while retracting. It does a little bit of an extra movement after it gets done with the retraction, trying to keep it from blobbing, but Pressure Advance should help that as well. So let's turn that one off for now. But check for coasting as well. I believe Cura calls it coasting. Now we should be able to go ahead and slice and print this out. And here's what our print looks like. For this extruder, a 0.02 was pretty much the sweet spot. But what you're looking for is down here when we start in the low range, you can actually see the seam has a bit of a hump. And then as we get towards the top, it's starting to get just a bit of a gap. You can see it right here. So it's pulling back on the filament too much, but not enough down here. So you're looking for the section that gives you the smoothest finish without causing a gap. So on this print, just based on how we set up the G-code, our sweet spot is going to be anywhere from 75 layers to 125 layers. And again, this is 0.2 layer height, so in between 15 and 20 millimeters from the bottom. So 0.02 started right in here, 0.025 right in here. And you can kind of see there's no gap, but it is nice and smooth. So that's the easiest way to tell how you dial in your setting. You can also print the cubes because it is kind of easy to see on the edge, but this gives you a little better representation. And because of that, I actually continued on. Again, on the same Hemera direct drive extruder, this is 0.08 down here at the bottom, all the way to a 0.15. You can see how large the gap got. With a direct drive extruder, you don't need to do this one. I just wanted to show you how big a difference there was. If I hold my hand behind here, you can see there's a gap all the way down. Just to give you an idea of what the tests are going to look like. So back to our 0.2, the corners look pretty good. A 0.025 wouldn't be too bad either, but on the top, you can see the corners are pretty sharp. So that's a fair setting for this. But I did do some more tests, like this one. This is a setting of 0.05. And this is what you need to look out for. If you get it too high, they're going to start to be really rounded. They're not sharp at all. Also, you notice it's missing some filament here and there. And that's the next thing we need to talk about when you're setting up Pressure Advance. So here's a cube I did with the infill exposed, just so I can explain what's going on here. This is with the 0.2 setting, so it's the right setting for this extruder. I just want to point out a few things. So when we have our Pressure Advanced on, we're coming through here, we're extruding, we're accelerating, we're deaccelerating, and then we're going to try to pull back on that filament before we get over to the end, so we can have sharper corners, more accurate extrusion. And that does work. But if you get it too high for your setup, you're coming through here, you're printing, you're accelerating, deaccelerating, then you're going to pull back too much on that filament, and you're going to cause gaps. So you didn't have enough filament to make it all the way to the point where you need to stop extruding and then continue. And you're going to notice that most in your infill. But you saw in that 0.05 cube, we actually saw it coming out a little bit on the top finish. So when you're setting this up, definitely pay attention to that, and there are ways to compensate for it. And to show you a really extreme case, this is what the corners look like. This is a 0.1 setting on a direct drive extruder. They're actually cutting off the extrusion, so there's a valley in here before it even makes it to the corner. And if you look on top, it's not even connecting the top finish, so you can imagine what the infill in here looks like. It's probably not connected at all. So that is the trade-off to Pressure Advance. And if you have it set up right and calibrated, you don't have to worry about this. But if you do need to compensate, let's head back to the slicer. Most slicers are going to have a setting like overlap. So if you have a longer Bowden tube or a specific configuration where you think you have to set Pressure Advanced up kind of high, and you start not getting the kind of overlap, or the infill isn't connecting like you want to, check out a setting like this. Stock on my profile, I use 25% just to give it a little bit more overlap so I ensure the integrity of the part. Different slicers do this differently, of course, but you might consider increasing this just a little bit to get your part dialed in exactly how it should be. So Pressure Advance is actually pretty straightforward to get set up. That's mostly in part because Duet has great documentation. The settings that they give you for different configurations of 3D printer are pretty spot on. I really didn't have to calibrate much outside of those parameters. Of course, there's a few things to watch out for, like that overlap. You want to make sure that the infill is getting to the outside of the wall just as it should. And there are a few other considerations. But at the end of everything, using RepRap Firmware, I think you should just go ahead and turn it on. Turn it on for the recommended setting that they have out there on the site right now, and just see if your performance gets any better. And there's a couple of ways that it can help you. Not just with print speed, but making retraction more efficient. Now a little higher end, all metal hotends like V6s, Mosquitos, and the one that's on the Hemera don't need much retraction at all. I run mostly with mine setting around a 0.5 or 0.6. But just as a test, I lowered this one down to a 0.1. That's 1/10 of a millimeter in distance that it pulls it back when changing direction. And you can see just how stringy it is. This is with Pressure Advance off. Now it might be hard to see the difference, but this one is with Pressure Advance on. So let's just take a look at them a little bit. Pressure Advanced off, you can see how thick the strings are up here. It didn't get enough retraction, so it's dragging the filament over. The same on this side. So there's a lot of oozing going on here, but that's what you would expect with almost no retraction. Then if you take a look at the one with Pressure Advance on, again, this one has 1/10 of a millimeter of retraction. We actually see just a little bit more solid filament coming out, but not those dense strings like we saw on the other one. So it's not going to get you out of retraction by any means. You still need it, but it might save you 1/10 of a millimeter here or there, depending on the setup that you have. Direct drive, it's not going to matter so much, but maybe on a Bowden setup, it will. So if you're going to set it up after you dial in your Pressure Advance, definitely play around with your retraction settings. Maybe you can bring them down just a bit. Just one more side by side because it is kind of hard to tell the difference. This is with it off, this is with it on. So definitely play around with your retraction settings after you get Pressure Advance set up. You might be able to save yourself just a little bit of time here or there, depending on how long the Bowden Tube is. And speaking of Bowden Tube, let's move to a Bowden printer just to see how Pressure Advance works there. So here's my example. I'm going to try to show you what's going on here with Bowden tubes. So I've got the tube and the filament clamped down on the other side to simulate it being pushed up against the hot end. But just imagine the extruder is driving the filament. As it drives it and tries to retract, you can see it actually moves in here, even though the other end is clamped down. That's because the filament has to be just a little bit smaller than the tube, or it won't work. And that introduces this slop. And that's what Pressure Advance is really good at taking up the slack for. And to add to that, if you take a look at the middle of the tube, they call it elasticity in the filament, but the tube just has that slop. So when you push on the filament, you can see the filament move inside the tube a bit. You can see the filament actually running in a different curve than the tube is, but then you pull it in, you can see the tube tighten up. I know it's hard to see, it's a very small increment, but you push it in, pushes to the outside. Pull it out, pulls to the inside. So the longer the tube, the bigger this issue becomes. The Pressure Advance actually pulls back on the filament just a bit to try to compensate for some of this. So to start tuning the Bowden style printer, I thought it'd just be easiest to start with the Ender 3. This one does have the Panica Kinetica G2C board in it, and it does run RepRap firmware. This one has around 450 to 500 millimeters of Bowden tube, so not a huge tube, but long enough to test it out. And there are, again, a couple of ways to tune in Pressure Advance. You could go ahead and try to print that box like we did for the direct drive. That will work, but you're going to have a lot larger increment when tuning a Bowden printer. I think the easiest way to see it is by printing the Linear Advance scale, the one from the Marlin page. And it does use a different syntax, but I'll show you how to get around that. So let me show you how to get all the code and everything for it set up first. So here's the page where you can set your K factor in Marlin for a calibration pattern so you can see what Linear Advance is doing. We can do the same thing for Pressure Advance. It works the same. So for an Ender 3, here are the settings that I'm going to use. I'll go ahead and leave it at 205 for the nozzle temp, leave all these default. Retraction distance, I'm going to try to set it to somewhere close to what I would set it for normal prints. So I'm going to set mine to 4. Layer height at a 0.2 is fine. We'll go ahead and update our bed size. I'll set it to actual size, 235. 235. Leave the print settings the same. Slow speed 20, fast speed 70, movement 120. This is because it's going to do a slow movement, ramp it up, and then do a faster one so that it shows you what the Pressure Advance will do to help catch up. Retract speed at 30 is okay, acceleration 500. These values really don't apply to us because it's not going to work the same with RepRap, but it will work in this case. Linear Advance, you can just leave this at 1.5. We have to be concerned with our K values. So again, Duet has some specifications out there on their page of what you should start with a certain amount of Bowden Tube. I think those values are just a bit low. So I'm going to start with a value of 0, and I'm going to go all the way to 2. Now it's actually a 0.2 for Pressure Advance, but I'll show you more on that in a bit. I'm just going to leave it set like this. And the stepping, I'm going to have it do it a 0.1 at a time. So that should give us 20 lines. You can adjust the lengths of the test line if you wish. Default should be okay. Line numbering, that makes it much easier to tell what line's what. That just puts a number out to the right side, so we'll leave that intact. If you need to do anything about auto bed leveling before you run the test, Z offset, all that's here. But since we don't have any of that, this all should be good. Now, let's go ahead and generate G-code. Here's your G-code out to the side, and you can see it's using an M900K value. All we need to do is change that up to be able to use that M572. And the easiest thing for me to do is always use Notepad++. You can download the file right here, and we'll open that up in Notepad++. And we're just going to do a replace anywhere there's an M900. So I'm going to do search, replace. So we want to see the M900 K value. And we can leave the value where it is because we can reuse that for our M572. So we're going to replace it with an M572, D0 to select the extruder we want. If you have multiple extruders, you can use them right here, D1, 2, 3, and 4, and so on. And then S. So that will leave the values that we put in the generator intact. And let's just do replace all. You can see the first line, we turned it off, D0S0, D0.1, 0.2, and so on. And these are a lot bigger increments than when we did the direct drive, but you'll see how this is going to impact it in a moment. Now you can just save this and upload it to your DWC, run it off your SD card, whatever you want, but just print it out. It should do all your preheating and all that for you. You shouldn't have to do anything special. And when you print it, you get something that looks like this. Now, it's going to be kind of hard to tell the difference in between all of these lines, but you want the one that looks the most consistent. Some of these are going to be fat on one side, thin in the middle, fat in the middle. You want the one that's the most even all the way across. If you want to get really granular, go with that line, and then go back and regenerate the G-code in smaller increments to even get a finer tune. But just with the 10th measurement all the way up, you can get it really close. And if we zoom in, if you look at them all across the board, I think 1.3 is the setting for us for this Ender 3. You can see 1.0 right here. It's still just a little bit thin in the center, a little bit fat in this section. Same for 1.1. 1.2 is almost perfect, but I would say it's still just a little bit too fat right in here. 1.3 is the most consistent across the board. From where it started to where it finished, you don't see it balloon out hardly at all. Because remember, you're coming across at a slow rate, it automatically speeds up instantaneously, and then it slows back down, creating these inconsistencies. And as you go up the line, you're going to see them really fat right here because it pulled back on it too much, and then it automatically got super thin on the end. And that's the same kind of effect that we saw with that cube where we had it set too high on the direct drive extruder. It's not finishing the end of the line with enough filament to get it connected to the infill or complete the surface. So I think 1.3 is our setting here. So now I'm going to head back to the DWC for the Ender 3 and update that Pressure Advance setting. You can do M572, D0, that's the extruder we have, S, 1.3. You can do an M572 again to check and make sure it's updated. And there's our setting. Now when you're calibrating Pressure Advance, there's one setting on the machine that you need to be concerned with, and that's instantaneous movements for the extruder. There are processes that do this called jerk or junction deviation, but let me show you the setting on the RepRap Firmware side. We'll just go to Settings, System Editor, Config.g. In RepRap, they do an M566 to set instantaneous speed changes, and that is in millimeters a minute. Sometimes these will be set too low to make the instantaneous changes that Pressure Advance wants to do. So if you think it's not working correctly, this might be your problem. Mine was initially on the Ender 3 set at 800. I've got this one commented out, and I created a new one down here to change it to 1500. So the higher you get with the Pressure Advance setting, the more it's going to need to move, and you want that move to be instantaneous. In other words, you don't apply any acceleration. So make sure this setting is set high enough. 1500 is probably high enough for most extruders. Depending on the tube, you might need to make it a little bit bigger, but start around 1500, you should be okay. After we've checked all that, I'm going to go ahead and do a test print so we can compare it with it on and with it off, just like we did before. Our test print at a setting of 1.3 is done. Let's have a look. So the first thing I notice is the top finish, and you can see it's a little sparse on the corners. Now I did increase the infill overlap on this one to 35%, but I might need to go just a little bit higher than that. What's happening is when the extruder gets into the fast moves, these layers don't have a very long print time. It's having a hard time doing that backlash movement fast enough to keep being able to put that much filament down. With a little more overlap, or maybe increasing the extrusion rate just a little bit, you could combat that, but it's going to take just a little bit more tweaking. But taking a look at the front of the cube, the corners are much sharper. You can see that from the top as well. But let's take a look at this one versus the one where it's turned off. So this gives you a pretty good look at the corners on the one where it's turned on, the 1.3 setting. You can see that corner is nice and sharp. So is this one over here. Versus the block where it's turned off, you can see the corner is pretty pinched. So it's definitely doing its job, but it's going to take just a bit more tweaking. Again, extrusion rate might be able to fix this problem. You can probably adjust the multiplier. Next test, I'll probably try just a bit more overlap as well. I did also stop the first one just so I could give you an idea of what the infill looks like when the overlap is set that high. You might not necessarily see it on the infill movements, but you might on the bottom and top layers where it's trying to fill it in. Just keep an eye out when you're tuning it in. And I wanted to run these two prints again just to give you an idea of what you can expect to see out of the extruder when you're tuning in Pressure Advance. This is with Pressure Advance off. Watch the knob, you'll see the usual retraction pullback, but not the snap that you're going to see with Pressure Advance. And here's what it looks like with Pressure Advanced enabled with that setting of 1.3. At the end of every movement, there's a little bit of snapback. So Pressure Advance does work on the Ender 3 with this Bowden setup, but there's a little bit more tweaking that's going to need to be done. You're going to have to find your correct Pressure Advance setting, as well as retraction, and then try to compensate with maybe some extrusion settings or some infill overlap. I do believe there's a happy medium somewhere in there where you could get a better print quality. I'm just not sure it's worth all this tweaking. It does work a lot better on direct drive setups. And that's kind of the same situation that you have in Marlin with Linear Advance as well. But I am really curious, how's it going to work on a printer that has a really long Bowden tube? And I just so happen to have one of those on the E3D tool changer. Those run Titan extruders into V6 Hotends, and I have almost 800 millimeters of tube. So let's test the tool changer out as well. So basically we're going to do the same thing on the tool changer because it has a lot longer tube. We're going to run the same calibration pattern that we did before. We're just going to change up some of the numbers. The first one being the retraction distance. I run around a 5 on the tool changer. These are Titan extruders, Bowden fed V6 Hotends. Bed size is a 300 by 200 on this machine. I'm going to keep all the printing speeds the same. And then my K values, I know that it's going to be over a 1.3, but I'm not exactly sure how high it's going to need to go. So let's take it all the way to a 2.6. We'll still do increments of 0.1 Remember, you might start running out of room on your bed if your bed isn't big enough. This one's only 200, but we should be able to get by with this. So we can go ahead and generate G-code one more time. I just renamed it with a TC on it, and we can download the file. Back to Notepad++, we'll open that up and make our changes. Again, just replacing anything M900K with an M572. Just like we did before. I'll just go ahead and hit replace all. I am using the first extruder on the tool changer. If you wanted to use one of the other ones, you can change it with this D0. It'll go D0, 1, 2, or 3. But the first extruder should be fine. And then we can go ahead and run this test. And here is our tool changer scale. Now I have to show you these via images because it's really precarious to get video footage where the tool changer is, but hopefully you can see it well enough. Down here at 0, you can see it's super thin here in the middle, and it doesn't get any better here for a while. We probably can assume we have to go over a 1.3. Now some of my numbers didn't come out, but I did get a better shot of some of the higher numbered lines. Here we have our 1, 2, our 1, 4, all the way up to 2, 6. And I have to say, after looking at several pictures, I'm not real happy with any of these, honestly. Some of these at the bottom don't compensate enough, but then it's not quick enough to back it out at the bottom to keep it from being so fat at the end. If I had to choose, I'd say 1.2 was the winner. So let's go with that and see what we can make it do on the test print. And remember, on the test print, you might consider adding a little bit of overlap for the infill. Let's go 35 again, like we did for the Ender 3. That's 35% overlap. And depending on how the print looks, you might need to adjust your extrusion multiplier. And I know it seems like we have to change a lot just to be able to use Pressure Advance, but I think there is a scenario that you could get it set up where you would achieve a lot better prints. Again, the Bowden machines aren't the easiest ones to configure. And like before, make sure that your speed changes for the extruders are quick enough to use that feature. I've got them set to 1500 on the tool changer. Now let's do a test print and see how it turns out. We'll set it with an M572 D0 S 1.2 and we'll kick off our print. And while our tool changer test print's going, I wanted to show you a couple of ways you can use that M572 setting once you've calibrated it to a setting that you like. You can set it in your RepRap config file. So back to settings, system editor, config.g. I've got some commented out down here, but you can set them static if you're always going to use the same filament. But PLA and PETG as well as TPU, they're not all going to be the same. So this probably isn't the best way to go. You'd be better off setting them in your slicer. And I suggest you set them in your slicer in your filament specific G-code files. So let's go to filament settings. Again, I use Prusa Slicer. And then whatever filament you have, go to custom G-code and put your M572 commands right here. So for PLA, for the tool changer, I would do M572 D0 S 1.2. And I could use some if statements, or I could just create a new filament for each extruder, but I would have to increment those for D0 for the first one, 1, 2, and 3. But that's the best way to tune each extruder. I might have a different hot end on there, it might have a different setting. Then when you select your new filament profile, your Pressure Advance setting will go with the filament setting. So the test prints on the tool changer didn't go so well. Anytime we have a higher Pressure Advance setting, the extruder just grinds through the filament. It's not able to move the filament like Pressure Advance wants it to with that long of tube in this extruder setup. Now, if it was a different extruder or maybe set up just a little bit differently, maybe we can make it work, but not on this one. I did try several different settings to see what it was capable of, so let's go ahead and take a look at them. So on the tool changer, I just did a regular test cube like we were doing. This is with Pressure Advance turned off. You can see we have a little bit of pinch on the side there. Pretty typical out of the tool changer. But I wanted to compare that with some of the other test prints. Here's a test cube with Pressure Advance set at 0.6. There's not much difference in between this one and when it was turned off. The corners really don't show any better print quality, as well as the top. In fact, on the top of the one at 0.6, you might be able to see just a bit of under extrusion. But no help there from Pressure Advance. And if you set it any higher than a 0.6, this is set at 0.8, it gets completely under extruded. There is almost no infill inside this print. Anything higher than that, it just printed in air after the first layer, couldn't get the print to complete at all. So Pressure Advance probably isn't going to help us that much in this scenario. Like I said before though, different extruders, different printer setups, maybe you could go this high, just not in the configuration that I have without a ton of tweaking. So there it is, the Pressure Advance feature in RepRap Firmware. And I do think it's worth your while checking this out, especially if you have a direct drive machine. It didn't take too long to get it set up on that printer. I didn't have to do much calibration. I pretty much used the stock settings, and I did see an improvement in print quality. Now with Bowden style 3D printers, we're kind of in the same boat as we are with Linear Advance and these types of settings. It's going to help you the most on a Bowden setup, but it's also the one that's going to be really hard to configure. And I don't know if the bump in print quality, like we saw in the Ender 3, is worth your time with all the tweaking you're going to have to do with the Pressure Advance settings, as well as compensating for it inside your slicer. And with the even longer Bowden Tube machines, I'm not sure if there's a configuration out there that will actually work with the Pressure Advance setup, but if you know of one, please leave it in the comments below. So that's it for today. I hope you found this helpful, and I will see you on the next one.